I'm Richard Gage, AIA, 30-year architect, member of the American Institute of Architects, and founder of Architects and Engineers for 9/11 Truth. We're a nonprofit organization of now more than 3,000 architects and engineers signed on to the petition demanding a new investigation into the destruction of all three World Trade Center skyscrapers on 9/11. I'm joined today by civil engineer Roland Angle, director of our Project Due Diligence outreach effort to the engineering community. Roland graduated from UC Berkeley and began his career designing hardened missile silos to withstand nuclear blasts. He went on to a broad career in civil engineering and the construction fields spanning the last 50 years. Let's bring him in. Hi, Roland.
Hi, Richard.
Hey, you doing well?
Yes, I am. Thank you. Hope you are too.
Yep, I'm excited about today because we're here with you guys in order to announce the completion of the final report of the 4-year computer modeling study of World Trade Center 7 performed at the University of Alaska Fairbanks. Roland will be giving you the highlights of the study that was led by Professor Leroy Halsey and his team of PhD researchers at UAF. Professor Halsey is a forensic structural engineer of 50 years also, and served as chairman of the Department of Environmental and Civil Engineering. The UAF team has conducted a robust finite element analysis of the collapse of this 47-story skyscraper, the third to collapse on 9/11, which so many know literally nothing about. If you are among those, then you may be surprised to learn that this high-rise fell suddenly, unexpectedly, at 5:20 in the afternoon, 7 hours after the Twin Towers were destroyed. It fell symmetrically at freefall acceleration in under 7 seconds, in the exact manner of a classic controlled demolition. Yet NIST, the National Institute of Standards and Technology, who was tasked by Congress to explain these collapses to the American people, claimed in their 1,000-page report, issued 7 years after the collapse, that it fell due to normal office fires. But this has never happened to a steel frame skyscraper before 9/11. So we've got some important learning to do today. First, though, I'd like to say a hearty thank you to the thousands of concerned citizens who we worked with to fund the university in performing this historically important work. Roland is here to give us all his insights into this important study and to present his startling conclusions. Well, it's the UAF startling conclusions anyway. Ready to go, Roland?
I'm ready.
All right, let's rock and roll.
Okay. Today, the report, which is officially titled A Structural Reevaluation of the Collapse of World Trade Center 7 by the University of Alaska Fairbanks, is, we're going to discuss that. It was just issued yesterday for the first time. We want to thank Professor Halsey and Dr. Zhao and Dr. Kwan for their 4 years of hard work to produce this report. It is a milestone in the development of our understanding of what happened to the building that day. Professor Halsey was originally approached back in 2015 and asked to investigate this third unprecedented high-rise failure. And he initially refused us 3 times, but eventually he said yes. And the reason he said yes is because he understood the nature of the problem. The NIST report said that the building had collapsed due to fire. And they also said that no other tall steel frame building had ever failed due to fire. So it was essential for public safety that we understand the failure mechanism of this structure. And since the NIST report said that it had failed due to the unprecedented event of office fires, Professor Halsey understood that this was a matter of supreme importance for our profession. The science behind the study was first examine the fire loads, which were supposed to have caused the failure on floors 12 and 13, and then determine how the building was going to react to the thermal loads. And secondly, rule out scenarios that couldn't have caused the failure. And third, identify the type of failures and locations that could have contributed to the observed collapse. He used the same material properties that NIST used in their report to ensure that the input values for the materials would be the same. First, he simulated the local structural response to fire loading to floors 13 and below, which is where the fires were. Then he examined the NIST collapse initiation hypothesis and the hypotheses advanced by the private engineering firms whose studies were commissioned as part of litigation related to the collapse of the building. And third, to simulate the numerous failure scenarios within the overall structural system that could have possibly led to the total collapse as it was observed. The buildings and their relationship to one another are shown here. The towers, 1 and 2, the North Tower and the South Tower, Building 7, which was a 47-story structure to the north of Building 1, which was about 350 yards to the north of, 350 feet to the north of the first tower. The reports that have been issued on the Building 7 failure are these. The FEMA report, which was a preliminary assessment, was issued in May of 2002. Then NIST, which was given the power by Congress to issue a report on the cause of the failures, issued their report on Building 7 in November of 2008. Then the Arup Group was hired by the plaintiffs, Con Edison, as a result of the fact that the Con Edison substation, which was built underneath Building 7, was damaged. They sued World Trade Center 7 in 2010. Then Weidlinger was another engineering firm which defended the World Trade Center properties in that same lawsuit. Their report, however, only became available in June of 2016 without their thermal analysis. And then our report, which was issued yesterday. The World Trade Center 7 building was the third high-rise to collapse that day. The location of the building was about 350 feet from the North Tower. It was 47 stories high. Each floor had about an acre of area. It was a trapezoidal floor plan. The gross floor area about 2 million square feet, and it was built through and over the existing 2-story tall Con Edison substation. It contained 82 columns in its floor plan, 58 on the perimeter, 24 in the central core. We see that layout here. The area of interest is in the northeast corner of the building where the red arrow is. That is the area that NIST identified as the place where the initial event causing the collapse took place. We'll take a look at that here in a photograph taken at the construction, time of the construction of the building. Looking west from that corner, we see the girder of interest, which is determined to be called girder A2001 in the plans. And we see the beams coming in from the east side of the building, framing into the girder. This is a plan of the foundation showing the caissons supporting the Con Ed substation and the connections of the beam of the columns of World Trade Center 7 building to those caissons. A photograph taken during construction. We can see the perimeter columns here on the outside, the girders connecting those columns, the framing, and over here above that, we see the core columns coming up through the floors in the area of the elevators and the stairwells. The 610-foot tall building, which was not hit by a plane, collapsed that day in the late afternoon at 5:20 and turned into a 5-story pile of rubble in about 7 seconds. I want you to look closely at the top of the building 7 there. We see some areas here that contain heavy equipment for the climate control. This is the east penthouse here. It's of particular significance, which we'll talk about later. This is the west penthouse. We're looking at this from the south. So I want you to pay particular attention to those features of the building. Now we'll take a look at what it looked like when it came down. Now these videos start after the east penthouse had already collapsed, because if you look at the top of the building there, you'll see that the east penthouse has already disappeared through the roof. And in all these videos, it's till we get to later in the presentation, you won't see the east penthouse because it collapsed first. Okay.
For the third time today, it's reminiscent of those pictures we've all seen too much on television before, when a building was deliberately destroyed by well-placed dynamite to knock it down.
Did they actually use the word brought down, and who was it that was telling you this?
The fire department, and they did use the word, we're gonna have to bring it down.
Oh, you go away. Go on.
We heard this sound that sounded like a clap of thunder.
Nikki, will you come and get the cat?
A shockwave ripping through the building, and the windows all busted out. About a second later, the bottom floor caves out. The building followed after that, and we saw the building crash down all the way to the ground.
And I turned in time to see what looked like a skyscraper implosion. Looked like it had been done by a demolition crew. The whole thing just collapsing down on itself.
It was almost as if it were a planned implosion. It just pancaked.
Here you can see the relationship of World Trade Center 7 to the World Trade Center 1, which is collapsing as this photo was taken. The debris pile from the two towers is shown here in a FEMA debris map. And we can see that World Trade Center 7 was hit by some light debris on the south face of the building. Here's FEMA's or NIST's representation of that damage. The damage in the lower southwest portion of the building is the area where the fires started, and it was presumed that it was the impact of the damage that caused those fires to start. However, NIST stated that the debris damage from the towers did not affect the collapse in any way. The fires themselves, at first, FEMA thought they were maybe caused by diesel fuel in the building, which would be used for the backup generators. That was later disproved. Most of the diesel fuel was found in tanks underneath the building. We do note, and NIST notes, that and we agree with this, the fires of concern were on the 7th, 8th, 9th, 11th, 12th, and 13th floors. The fires upper high at the 19th, 22nd, 29th, and 30th floors were out shortly after they began. So the NIST World Trade Center collapse theory looks like this. On floor 13, these 5 beams in the northeast corner of the building were heated by the fire. They pushed on girder A2001, which ran between column 44 and column 79, off of its seat, or in some, they have an alternative scenario, which we'll discuss, or maybe pulled it off. So they say it was either pushed off or pulled off its column seat at column 79. And that caused the girder to fall, and it hit the floor below, hitting the same girder underneath it on the 12th floor, breaking it loose. And fire damage also contributed to the other beams in the area at that area failing at the same time. And that left column 79 unsupported because the floors cascaded down all the way down to the 5th floor. So then you had a long unsupported column with a heavy load on it. It buckled, and then that caused the entire core columns to fail in a progressive manner, which then led to the failure of the perimeter columns, and that's what caused the building to collapse. So that's the NIST collapse theory. They said it was all due to the office fires, and the fires that they indicated were shown here in this photograph. You can see the fires have burned on the 8th floor. They've apparently come in from the west. They're burning in the central area of the building now. There were some floors on the 7th floor. You can see where the windows are busted out. The 12th floor, you can see that the fires apparently started on the east side. This is the east side over here. Here's column 44. And they burned their way to the west. And column on the 13th floor, there's fires that are still active in that area at this time. And this time was at about 3:50 p.m., which is about an hour and a half before the building came down. From the NIST report, we look at the information regarding to the local failure that initiated the whole event, namely the coming off of its seat of the girder A2001 at column 79. So this is column 79 here. Here's the seat that the girder sat on. It was supported by a plate, which was welded to the column. And according to NIST, that girder was considered to have lost its vertical support when its web was no longer supported by the bearing seat. The bearing seat on column 79 was 11 inches wide, so that when the girder end at column 79 had been pushed laterally at least 5.5 inches, it was no longer supported by the bearing seat. However, the drawings showed that the plate was actually 12 inches wide, not 11 inches wide, and NIST actually later admitted that when they were informed of that. Now, the NIST depiction of the girder sitting on its seat is shown here, and we see the web of the girder here sitting over the base plate, and it's got some clips what's attached to, and the plan view is here. You see the column with the girder coming in, sitting on the seat. However, there's a problem with their depiction, and that is there were stiffeners welded to the end of the girder, welded to both the web and to the lower flange. And this is the actual construction drawing, Frankel drawing, that shows that there were indeed stiffeners that were welded to the end of the girder. This makes a huge difference in their analysis. This is a pictorial view of the same thing. The support plate, the base plate, the girder, the beams that were pushing on it, and the stiffener plates, which were welded to the web and the lower flange. In the NIST presentation, this is the beam, the girder, and the column. And again, you've got the girder and the column here. There are no stiffeners shown. They did not include them. We know that they were there. Construction photos show that they were there. This is column 79. Here's the beam and the girder and the stiffener plate, clearly shown in the photographs. Now, when Professor Halsey and his crew did their finite element modeling of the building, they started with a model of the in abacus of the 12th and 13th floor. Here's the northeast corner, perimeter columns, the core columns here, the elevator shafts and stairs here. This is column 79 located here. The UAF study took the worst case scenario for the temperatures that were used for their model. This shows the 13th floor with the color showing the variation of the temperatures. They show it in Celsius, 675 Celsius. That's about 1,200 degrees Fahrenheit. So they show the deck here, the concrete deck. It sat on the framing, and we can see the temperatures that the various elements experienced. Here's the UAF finite element model of that northeast corner of the frame. You can see column 79, column 44, girder A2001, the 5 beams that frame into it from the east, and the perimeter columns. The finite element analysis that they ran showed, here we're looking at the critical point, the point of initial failure according to NIST. This is the girder, this is the beam that frames into it next to the column 79. Column 79 is not shown for clarity. We see the base plate though that was attached to the column, and the stiffener plate that supported it, the support plate. Here are the stiffener plates, which were welded to the web and to the lower flange. And the UAF analysis showed that even if we allow the beams to push the girder well past the corner of the support plate, the lower flange does not fold up and allow the girder to fall. So this, by the way, is a depiction that shows that the beam pushed it well beyond what it actually could have pushed it, because in order to get the girder pushed that far, the UAF had to increase the coefficient of thermal expansion of the beam by 40%, which is unrealistic. But they were trying to get this girder past the seat and find out what happened. They found out that the girder would not fall because the lower flange would not fold up. This invalidates the initiation event that NIST says caused the entire event. NIST later admitted leaving the stiffeners off of the girder. One of our researchers, David Cole, sent them a letter, and they sent back a letter, said the web stiffeners shown at the end of the girder prevent web crippling. The structural analysis of World Trade Center did not show any web crippling failures. Therefore, the web crippling plates did not need to be included in the models or the analysis. This letter was signed by the head of their public affairs office, Michael Newman. Michael Newman is not an engineer. No engineer would sign that document, I'm quite sure, because they would lose their license if they went on record saying that the web stiffeners would not have any effect on the flange stiffness. Other problems are that the column 79 and all the columns had built up side plates 2 inches thick that were welded to the column at every floor connection. They protruded 1.8 inches past the flange of the column. So when you heat the beams and you heat the girder, now NIST model said that the girder was heated to 500 degrees centigrade. Therefore, it would expand. That would push it up against the flange of the column. And when the beam attempted to move it to the west, it would get trapped behind the side plates. For some reason, NIST does not, although they showed the side plates in some of their drawings, they don't give any explanation for how the girder could have cleared the side plates and therefore come off of the support plate. So that is another serious problem with their analysis. Here we see that they had another problem, was that they left off these lateral support beams. Going back to the beams in the northeast corner, the northernmost beam had 3 stiffener beams that kept it from buckling between it and the exterior girder. So the NIST example, the NIST representation, which is shown here, this is a little bit harder to see. Here's the column 79 over here, and these are the beams. This is column 44 here, and there are no support beams shown here. So even though there were 3 support beams, they were not shown in the NIST analysis. What that means is that when NIST heated the floor, that beam buckled, and the other beams adjacent to it also buckled. The UAF report confirmed that if you left off these 3 beams here, this northernmost beam would buckle when it's heated. Now, the reason why NIST, I think, needed that piece of information to be omitted is because they also claimed that this girder could have been pulled off of its seat at column 79, and that would have been caused by the shortening of the beam due to the buckling, and the cooling process would have perhaps drawn the girder off of the beam to the east instead of pushing it off to the west. The UAF analysis showed that when you left those 3 beams in there, the beam didn't buckle, and therefore the girder would not have been pulled off to the east. But UAF went even further and said, okay, let's assume somehow that the girder could fall. What would happen then? NIST says that the girder would fall down, hit the girder below it on the 12th floor, break it loose at its connection, and cause that section of the floor to fall, which would lead to a cascade of floors all the way down to the 5th floor, which would then cause column 79 to be unsupported for all the floors between 14 and 5, which would then cause it to buckle due to lack of lateral support. Now, the analysis that everyone agrees with is that in order for this connection here at column 79 to be broken, the force that the impact of the girder above hitting it would have to be 632,000 pounds. That's what it would take to break the welds loose here and cause the 12th floor girder to collapse. So the UAF did a modal analysis of that framing section. Here we see it again. Here's column 44. Here's beam A2001, the 5 beams. They let it fall, let it hit the beam below, the girder below on the 12th floor, and they did an analysis. And what they found was that after you do the stiffness and you figure the frequency and you run through all these calculations, which I'm not going to bother to reproduce here, you only get a force of about 62,000 pounds for that girder hitting the floor below it. So that's only about 1/10 of what you would need, 632,000 to break it. And furthermore, if you heat it up to the temperatures that NIST says it was heated to, that force is reduced to about 48,000 pounds. So the conclusion is, even if the initiating event somehow could have occurred, which we know it can't, it couldn't have caused the next event in the progression to take place. Remember, they claimed this was a progressive collapse. First event, girder coming off the column. Second event, the girder causing the girder below it to break loose. So both of those steps have been shown to be impossible. Now, the linear static analysis that UAF ran, they took this scenario, they took the NIST analysis, said, okay, so we go to the next step. We look at these columns and we take these columns out. We say that they buckled down there between the 14th floor and the 5th floor, and we take them out. And then we take out the next columns that they say collapsed next to them in the core column, 76 through 78, and we see what happens. What happens is this. The collapse of those 6 core columns overloads the perimeter columns in the southeast corner of the building. And that causes the building to collapse by tipping to the southeast and falling over. This would be what that would look like. So the collapse scenario, the third step in the progressive collapse that NIST is proclaiming, would have resulted in a collapse of the building tipping over and falling down, not falling straight down into its own footprint. Notice again that the east penthouse is still intact in that scenario. Let's see if we can get this to move on. Okay. Now, the UAF also did a global collapse animation in which they tried to get the building to act as if it's shown in the actual footage. And this is what that would look like. See, the east penthouse collapses first, then the west penthouse, and shortly after that, the entire building comes straight down. The UAF finite element model was able to reproduce to a very close proximity the actual collapse mechanism. Here's another look at it from straight on to the looking north. They only got this to occur because they took out all the interior columns over 8 stories low in the building, followed 1.3 seconds after that by the perimeter columns. And that was the only way that they could imitate the actual event. In addition to that, prior to that, they had to take out the 3 columns, 79, 80, and 81 up here high in the building as a separate event to get that east penthouse to come down first. And then the building, the core columns after that caused the rest of the building to come down. So there's the upper floors underneath east penthouse, then the core columns down low, pulls down the west penthouse and causes the entire building to collapse. That's the only way they could replicate what we saw. Here we see a video of the event compared to the NIST model of the event. We'll see, here's the east penthouse. We're looking at this from the north. Same thing here. Down here in this corner, you'll see the area that NIST says caused the event to occur on the northeast corner of the building. See there, this is their event, which they say pulled down the east penthouse and caused the building to collapse. Compare with what's happening on the left. Notice the distortion of the building in their model versus the actual event. The NIST model also stopped about 2.8 seconds into the actual collapse once it began to collapse, and they never show the rest of it. This is a picture of what their model would have looked like a little further down the line, which shows that the top of the building swings around at more than 90 degrees to the central axis of the building, and clearly doesn't look anything like what the actual event looked like. The question of free fall acceleration was brought to the attention of NIST when a physics teacher, David Chandler, using a video of the event, proved that the entire roof line was in full free fall acceleration for about 2.5 seconds near the beginning of its collapse. NIST was confronted with this fact, and they were finally forced to admit it, but they never looked at the implications of that free fall. Here's what a graph of the collapse looks like. You can see this is the velocity, the time. For about the first 3/4 seconds, it started to descend. Then it went into free fall. This is the slope of free fall acceleration. And it followed that for about 2.5 seconds. And then it began to slow its descent as it encountered resistance from below. Now, if the column resistance had been actively activated by the collapse of the columns as NIST theorizes. When you buckle a column, the resistance trails off to about maybe a third of its total strength after the column has collapsed to a great extent. What this means is that the columns will always give some resistance to the collapse of the building. So that means that their model cannot account for free fall at all. So free fall is another fatal error, proving that their mechanism could not possibly account for what happened. In free fall, all the energy and the potential energy is converted to kinetic energy, and there's no energy left to do any other work. So the upper part of the building, if you took out 8 stories, could not have been crushing that portion of the building. So those columns were not available to give any resistance. So looking at the conclusions of their collapse analysis, we see that columns 79, 80, and 81 did not fail at the lower floors of the building. And in order to cause the east penthouse to fail first, while not having any deformation of the exterior, these columns had to have failed only at the upper floors of the building. But there's no documented fires above the 30th floor, so that is impossible from their perspective. Secondly, the hypothetical failure of 79, 80, and 81, the 3 easternmost core columns could not trigger a horizontal progression of the core column failures. So the hypothesis of NIST and the Arup and Weidlinger reports that the buckling of column 79 would trigger a progressive collapse of the entire building are invalid. And the collapse of columns 79, 80, and 81 high in the building would have had to have been a separate and distinct event. If we assume that the failure of columns 79, 80, and 81 could lead to the failure of the next row of core columns, the additional hypothetical failure of those 3 columns, 76 through 78, would then overload the exterior columns around the southeast corner of the building instead of overloading the next row of core columns to the west, and that would result in the building tipping to the southeast, not in a straight down collapse. And here is the conclusion that is most revealing and definitive for our purposes, and that is that the simultaneous failure of all core columns over 8 stories followed 1.3 seconds later by a simultaneous failure of all exterior columns over the same stories, the same 8 stories, produces almost exactly the behavior observed in the videos of the collapse. That collapse could have started at any of the various floors, starting at floor 16 and below, and produced the same behavior. So here we have definitive proof that the observation that most people make when they see the building collapse, that is, looks like a controlled demolition, is validated by the study showing that a progressive collapse was not possible. It had to be an almost simultaneous event, which could only be accounted for by a controlled demolition event. So this proof here, together with the preceding proofs that the progressive collapse could not have occurred, is fundamental to our claim that we need to have a new investigation of the building's collapse. Lastly, the conclusion that the study made, that the UAF study, was that this is a global failure, that it had to be near simultaneous failure of all columns in the building over 8 stories, and not a progressive collapse involving sequential failure of columns in the building. And despite the UAF team's simulating of a number of hypothetical scenarios, they were unable to identify any progressive sequence of failures that could have taken place that would have caused a total collapse of the building, let alone an observed straight down collapse with approximately 2.5 seconds of free fall and minimal differential movement of the exterior. So at this point, I would like to thank you for your time and joining us today to see this webinar about our report, about the UAF report that was released yesterday. And I want to call on all my engineering colleagues and our building professionals in all fields to join us in demanding a new investigation into the collapse of this building. The NIST report does not explain it. The UAF report gives us the evidence that we need, rigorous scientific and mathematical proof that the only way that that building could have been brought down was by controlled demolition. And we, as building professionals, need to make it clear that the event that we have been told was caused by a progressive collapse that day due to office fires did not occur in that manner, and we are not going to support that report. We need a new investigation, and we need to have it conducted in a scientific manner. And we call on all academic engineering departments to follow this study, to assign their students to study the differences between the NIST report and the UAF report, and to join us in calling for a new investigation. And I want to thank everyone that has participated, especially Dr. Halsey and his team, and the other many volunteers that have helped us bring this information forward at this time. We have created a milestone in our progress towards a new investigation today. Thank you.
Thank you, Roland. That was a lot of powerful information. You know, I was particularly impressed by the conclusion that in order to produce in the finite element analysis the collapse as we saw it, symmetrical at freefall, they had to, in their computer model, take out all 80 columns on at least 8 floors all at once. Well, what can do that? I mean, this is like the remaining question here, right? Well, there's answers to that question on our website, ae911truth.org. But also, I encourage you to search on YouTube for 9/11 Experts Speak Out. You'll find our documentary, which highlights 40 high-rise architects, structural engineers, metallurgists, chemists, physicists, controlled demolition experts, all laying out the evidence as to what could have caused this. And by the way, if you're hearing about this subject for the first time, don't feel too overwhelmed or do. It's natural. We hope that you found the webinar illuminating at least, and that we're able in this short period of time to adequately explain some of these scientific concepts involved. We encourage you to download the report, though, and read it. It's about 130 pages that we condensed today. And you can do that at ae911truth.org. Also, you can go to the university website, ine.uaf.edu, and take the time to try to understand the differences between the Halsey report and the NIST report, and draw your own conclusions and see which better explains these two collapses that you've seen now in the videos. You can also submit your questions for Roland and I at ae911truth.org on the Contact Us form on our website. And if you're so moved, we also invite you to sign our petition demanding a new investigation into the destruction of these 3 skyscrapers. You'll learn a lot more information about the Twin Towers destruction in the documentary that I mentioned. And help us also to bring the investigation, force the investigation by bringing it to the attention of fellow engineers. So you can sign the petition at ae911truth.org. The more engineers that we have raising our voice, the more Congress will listen and be forced to open a real investigation. Also, we're just days away from submitting a request for correction under the Data Quality Act to NIST, which will force them to correct their deeply flawed report because it's based on the findings in the Halsey report here. And if you're a structural engineer, we highly encourage you to sign on to this request for correction by emailing us at rfc@ae911truth.org. Even if you're not listening to us live, but on the archived video, we can still amend your name to the request for correction. Just email us at rfc@ae911truth.org if you're a structural engineer or an architect with experience in steel frame buildings. A special thanks to you, Roland, for the insightful presentation today.
Thank you, Richard, for all you've done.
And thanks. And a thumbs up to Professor Halsey and the great team of PhD researchers at the University of Alaska at Fairbanks. We're proud to have supported the university in performing this truly scientific study. Thanks for everybody for joining us today. And we'll catch up with you next time. Bye for now.